Very good afternoon to all. We will start with today's 5 questions. Okay. So first question is from electrostatic potential. A thin spherical shell is charged by some source. Potential difference between the 2 points C and P as shown in the figure is. Radius of the sphere is given 3 centimeters. Charge on the shell is 1 microcoulomb. Okay. So ಇದೊಂದು ಸ್ಪೆರಿಕಲ್ ಶೆಲ್ ಇದೆ, ಇದರ ಮೇಲೆ ಚಾರ್ಜ್ Q 1 ಮೈಕ್ರೋಕೂಲಮ್ ಇದೆ. There are 2 points C and P. Potential difference ಕೇಳಿದ್ದಾರೆ. Okay. See, we know that potential at any point on the surface of this sphere, any point on the surface is nothing but KQ by R. Okay. And inside this spherical shell, the potential will be constant. A constant value ಎಷ್ಟಿರುತ್ತೆ ಅಂದ್ರೆ it is the same as the value of potential on the surface. So potential at C will also be equal to KQ by R. Okay, so potential difference between these 2 points Vp minus Vc will be directly 0, correct? So option D is the correct one. Okay, we will take up the second question. See, this question is from logic gates. Okay, logic gates, Antara, it's a favorite question for NEET. The output Y of the given logic gate is similar to the output of, okay. See, if you just look at this, this is a NOT gate, okay. So A will come out as A bar. Idu NOT gate now. So here this will be A bar, B bar, sorry. So A bar and B bar will go inside as inputs. So here, see, this is 11 bubble, right? So this will come out as Y is equal to A plus A bar plus B bar, the whole bar. A bar plus B bar, the whole bar. This will be equal to, as per De Morgan's theorem, this will be A bar bar dot B bar bar. Okay. So A bar bar is nothing but A. But B bar bar is nothing but B. So the output Y is equal to A dot B. So A dot B under AB input ಕೊಟ್ಟಿದ್ಮೇಲೆ, if A dot B is the output, this is a very standard gate and it is nothing but it is the AND gate. Fourth option. Okay, now we'll take the third question. Third question, no. It's on wave optics. If the monochromatic source in YDSC is replaced by white light, then okay, interference pattern will disappear. There will be a central dark fringe surrounded by this central bright fringe, white fringe surrounded by few colored fringes, and all bright fringes will be of equal width. Okay, so this is a standard question. YDSC only, if we replace monochromatic light by white light, see, the central bright fringe will remain. Okay, central bright fringe will remain. It will remain white. Central bright fringe remains and it will be white. Okay, and there will be a few colored fringes. Okay, now see, fringe width beta is equal to lambda capital D upon small d. Fringe width, it will depend on lambda. Okay, so lambda andre color. So bare color bare fringe width irtav. So violet, lambda violet is the shortest and lambda red is the longest. So central bright fringe, it will remain. So nearer to the central bright fringe, you'll have violet color, and then as we go far away, we'll have the red color. Okay, so the correct option will be, there will be a central bright fringe white surrounded by a few colored fringes. So third option is your correct option. Okay, it will take fourth question. It is on instruments. Vernier calipers, n+1 divisions of the vernier scale coincide with n divisions of the main scale. If 1 MSD, main scale division, represents 0.1 mm, then the vernier constant is, okay, very straightforward questions. Okay, if you just see what is given, n+1 vernier scale division is equal to n divisions of main scale and ಕೊಟ್ಟಿದ್ದಾರೆ, right? So n into MSD. Okay, so from here we can get 1 VSD. 1 VSD will be equal to n upon n+1 MSD, correct? Now ಏನು ಕೇಳಿದ್ದಾರೆ ಇಲ್ಲಿ, ವರ್ನಿಯರ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೇಳಿದ್ದಾರೆ. Okay, vernier constant, or it is also called as least count. This is equal to 1 MSD minus 1 VSD. Okay, so 1 MSD minus, for VSD we can put this value, substitute 1 n upon n plus 1 MSD. So it's simplify ಮಾಡಿದ್ರೆ we get n plus 1 minus n upon n plus 1 MSD. nn ಹೋಗುತ್ತೆ. Okay, but this is 1 MSD is given as 0.1 mm ಇದೆ, right? So 0.1 mm, 0.1 mm, which is equal to 10 mm is 1 centimeter, right? So this is 10 mm is 1 centimeter. 1 centimeter. So 0.1 mm means 0.1 divided by 10 centimeter, which is equal to 1 upon 100 centimeter. So here what we have to do is, if you want this in centimeter, we should just divide this by 100. So 1 upon 100 into n plus 1 is centimeter will be the answer. Okay, if you just look at the options, maybe, okay, C option correct ಆಗುತ್ತೆ. Okay, we'll take the fifth question now. Last question, it is on mechanical properties of solids. Maximum elongation of a steel wire of 1 meter length if elastic limit of steel and its Young's modulus respectively are this and this is. Okay, so maximum elongation of the wire कहता है इधर. Okay, what is given? First we'll write, okay, length ಕೊಟ್ಟಿದ್ದಾರೆ, length is 1 meter. Then elastic limit of steel is given. Elastic limit is 8 into 10 to the power of 8 Newton per meter square. Young's modulus is also given 2 into 10 to the power of 11 Newton per meter square. Okay. ಕೇಳ್ತಾ ಇರೋದು elongation. Okay, so elongation, maximum elongation ಕೇಳ್ತಾ ಇದೆ. Okay, so we know that Young's modulus is nothing but stress divided by strain. Okay, this stress will keep as it is, and strain can be written as change in length upon original length. Okay, now here delta L is the elongation, L is the original length. So if you write delta L upon L will be equal to stress divided by y. Okay, but we want elongation, so delta L is equal to, this is stress into length upon y. Now in the question maximum elongation is asked. Okay, so this stress will be nothing but, this will become the elastic limit stress, which is already given, elastic limit of steel. So for maximum elongation, if you want maximum elongation, then this will be equal to elastic limit. So direct substitution, this is 8 into 10 to the power of 8, L is given as 1 meter, and this is 2 into 10 to the power of 11. So 1s are 4s are, ಇದು ಮೇಲೆ ಬಂದ್ಮೇಲೆ this becomes 4 into 10 to the power of minus 3 meter. Okay, so meter ಅಲ್ಲಿ if you just convert to mm, this is nothing but 4 mm. So very simple question. If you look at the options, first option is correct.